Welcome back to our channel. Today, we're going to clarify an essential aspect of software development, the difference between verification and validation. While both are crucial for ensuring high-quality software, they serve distinct purposes. Let's break down what each term means and how they are used. What is verification? Verification involves checking the work products of a development phase to confirm that they meet the predetermined requirements. In other words, verification answers the question, are we building the product according to the design specifications? Verification is carried out through various methods such as reviews, inspections, and testing. It focuses on the correctness of the development process, ensuring that intermediate deliverables like design documents, code, and test plans adhere to the specified requirements. Key aspects of verification. 1. Goal. The primary goal of verification is to ensure that the product is being constructed correctly according to its design specifications and requirements. This means confirming that the product, during its development, adheres strictly to predefined standards and specifications. Verification helps in identifying issues early in the development process, reducing the risk of defects later on. It ensures that the system is being built according to the requirements set by stakeholders, and that all components are integrated correctly as per the design. 2. Techniques. Verification employs a range of techniques to assess the correctness of the product. Code reviews. Regularly conducted by peers or senior developers, code reviews involve examining the source code to ensure it adheres to coding standards, follows best practices, and meets the design specifications. This helps in catching errors early and improves the overall quality of the code. Static code analysis. This technique involves using automated tools to analyze the source code without executing it. Static analysis helps in identifying potential issues such as syntax errors, security vulnerabilities, and code quality issues, thus ensuring that the code base remains robust and maintainable. Inspections. Formal inspections are detailed examinations of the product's artifacts, including requirements, documents, design documents, and code. These inspections are often conducted in a structured manner with defined roles and objectives, aimed at detecting defects and ensuring compliance with requirements. Unit testing. Unit tests are designed to verify that individual components or units of the software perform as expected in isolation. This technique ensures that each part of the code functions correctly before it is integrated with other parts of the system. Design reviews. These reviews assess design documents and architectural plans to ensure they align with requirements and specifications. Design reviews help in validating that the proposed design will meet the desired performance and functional criteria. Walkthroughs. These are informal meetings where team members walk through the design or code with the goal of finding issues and improving understanding. Walkthroughs are collaborative and help in identifying issues early in the development cycle. 3. When? Verification is performed continuously throughout the software development lifecycle. During design, verification starts during the design phase where design documents are reviewed to ensure they accurately reflect the requirements and are feasible to implement. During implementation, as development progresses, verification techniques like code reviews and static analysis are employed to ensure that the code conforms to design specifications and coding standards. During integration, verification activities continue when integrating different components or systems to confirm that they work together as intended and meet design requirements. Before final testing. Prior to entering the final testing phase, verification ensures that all intermediate products and processes are accurate and complete, minimizing the risk of defects in the final product. Throughout maintenance, verification is also relevant during the maintenance phase to ensure that any changes or updates made to the software continue to adhere to design specifications and do not introduce new issues. By integrating these verification practices into the development process, teams can ensure that they are building a product that meets all specified requirements and is ready for further validation testing. What is validation? Validation, in contrast, involves assessing the final product to ensure it meets the intended user needs and requirements. It addresses the question, are we building the right product for the users? Validation is conducted by testing the complete software to see if it meets user requirements and performs as expected in real-world conditions. This includes activities such as system testing, user acceptance testing, UAT, and beta testing. Key aspects of validation. 1. Goal. The primary goal of validation is to confirm that the final product meets the actual needs, expectations, and requirements of the users. Validation focuses on ensuring that the product fulfills its intended purpose in real-world scenarios and provides value to the end users. It assesses whether the software performs its functions correctly from a user perspective and whether it solves the problem it was designed to address. Validation helps in identifying discrepancies between user expectations and the actual product, ensuring that the software is both useful and usable. 2. Techniques. Validation employs various techniques to ensure that the product is ready for release and meets user expectations. System testing. System testing involves evaluating the complete and integrated software system to ensure that it meets the specified requirements and functions as intended. This type of testing assesses the overall behavior of the system, including its performance, reliability, and compatibility with other systems. User acceptance testing, UAT. UAT is performed by end users to verify that the software meets their needs and requirements. During UAT, users test the product in real-world scenarios to ensure it performs as expected and that it is intuitive and user-friendly. Feedback from UAT can lead to final adjustments before the product is released. Beta testing. In beta testing, a version of the software is released to a select group of external users, beta testers, who use the product in a real-world environment. This stage helps in uncovering issues that may not have been identified during earlier testing phases and provides insights into how the product performs under actual usage conditions. Alpha testing. Often performed internally by the development team or a dedicated testing team, alpha testing is a preliminary validation phase that focuses on identifying critical bugs and usability issues before the product is released to external testers. Performance testing. This technique assesses the software's performance under various conditions, including high loads and stress scenarios. It ensures that the software can handle expected and unexpected usage levels without performance degradation. Security testing. Security testing evaluates the software's vulnerability to threats and ensures that it protects user data and maintains privacy. This is crucial for validating that the software meets security requirements and is resilient against potential attacks. Usability testing. This focuses on assessing how easy and intuitive the software is for users. Usability testing helps identify any design flaws or user experience issues that might hinder effective use of the product. Compatibility testing. This ensures that the software works correctly across different devices, operating systems, browsers, and environments. It helps in validating that the software provides a consistent user experience regardless of the platform used. 3. When. Validation is typically conducted after the development phase and during the final testing stages before the product is released. Pre-release. Validation activities are performed after the development is complete, but before the final release. This includes running comprehensive tests to ensure that the software meets all user requirements and performs well in real-world scenarios. During final testing. Validation occurs during the final testing phase, which includes system testing, user acceptance testing, and beta trials. This phase is crucial for identifying any remaining issues that could affect the product's usability and acceptance by end users. Post-development. Even after the initial release, ongoing validation may be necessary to ensure that the product continues to meet user needs as it evolves through updates and enhancements. During maintenance, validation also plays a role during the maintenance phase, especially when new features are added or significant changes are made. It ensures that updates do not negatively impact the existing functionality and that the software continues to meet user requirements. By incorporating these validation practices, teams can ensure that the final product is user-centric, fulfills its intended purpose, and delivers a high-quality experience to its users. Comparing verification and validation. Verification focuses on ensuring the product is built correctly according to specifications. Validation focuses on confirming the product meets user needs and performs its intended functions. Practical examples. Verification. Example. Imagine your team is developing a new mobile app. During the verification phase, you might review the app's design documents to ensure they include all necessary features and specifications. You might also perform static code analysis to identify potential issues in the code before it's even run. Validation example. Once the mobile app is developed, you would test it with a group of end users to ensure it performs well in real-world scenarios. For instance, you would check if users can easily navigate the app and if all features work as expected under actual usage conditions. This testing might involve collecting feedback from users and making adjustments based on their experience. Verification example. Consider a website development project. During the verification phase, you might use automated tools to check the code for compliance with coding standards and design guidelines. You might also review the website's wireframes and prototypes to ensure they match the project requirements. Validation example. For the same website project, validation would involve conducting usability testing with real users to ensure the website is intuitive and user-friendly. You might ask users to perform specific tasks on the site and observe whether they encounter any issues or difficulties. Verification example. In a software development project involving a new feature, verification might involve running unit tests to ensure that each part of the feature functions correctly in isolation. Code reviews would be conducted to verify that the feature was implemented according to the design specifications. Validation example. For the new feature, validation would involve integrating it into the larger system and performing system tests to ensure it works correctly within the entire application. User acceptance testing might be performed to confirm that the feature meets user expectations and solves the intended problem. Verification and validation are both pivotal in software development. Verification ensures the development process is followed correctly, while validation confirms that the final product meets user requirements and serves its intended purpose. Thanks for tuning in, and we'll see you in the next video.